Hello friends, welcome to the Laptex. My name is Nasser and today we have Dell Irish motherboard and very wonderful problem we have got. Today we will try to repair this and however the condition was, it seems that it is the water damage and already work has been done but the component is not changed, perhaps only IO is changed. And there is a marking of a scratch on the board. It's a good thing that they have tried to repair the motherboard, but what do we observe if we have the light on the motherboard available? Then we can figure out that what type of indication is there. So you just pay attention on the power supply and you will notice something. Now it is turned on and you will see the blinking, how you feel it. It seems there is a shorting somewhere, but if we start checking, and the condition is very, you can say that very mad, it is behaving like a mad. Sometimes it is turning on, display comes, sometimes it does not turn on, and when it turns on, keep on going whole day. So this type of problem. So it was repeat, it is repeat. I have repaired this motherboard and I worked on the PSL logic and I sent it to my customer and he said the same condition. So sometime we make these types of mistake. What does happen? You see that light is blinking, okay, the fluctuation mark here, and if we heat up the motherboard anywhere, you just see I am just heating up. Especially on the IO area, because I have worked on this. That is why when you repair the motherboard, you just got it successfully repaired and you call to the customer. Never do like that. What should you do? Let it be cool for 10 to 15 minutes and then check it again, and if it is successfully, then you just confirm to your customer that it is 100% repaired. Now still it is doing like that. So let me remove or do something on this area. Okay, I'm just removing the PSL logic area. Okay, I have just removed it and again I am going to fix it. Okay, now I will plug to the DC jack. Now you see the ampere and I think the fan is open. Now let me insert it. You will see the fan started spinning and ampere you can see. So I have worked on this motherboard and I thought that I have got it repaired because there was the problem on the PSL logic, but in fact I could not reach to the root cause. If I would have kept it for half an hour and again I would have checked, then of course I never have estimated to this motherboard. But now the scenario, as you can see, that it is turned on and display is also available. After few moment, when I will inject the power supply, again the same thing, the blinking and no turn on. Okay, so of course everything is okay as I checked. Now let me experience my this mesmerizing case with you, and let's begin that my PSL logic. So here is the LDO area, and let me close to the camera. Here is the 3.3 volt. The overview I am giving you. LDO is generated. You can check it. You can confirm it on the battery connector area. On off switch has the voltage. Everything is okay. Now 3.3 and 5 volt. Confirm 3.3 and 5 volt also. 5 volt and 3 volt. So everything is all right, but it is not turning on. And as you can experience here that the light is blinking. So now let me zoom my camera. So as you can see here that let me inject the power. Now you would be able to see nothing is happening. Yes, you would not be able to see because there is a much light on the this camera, this microscope. So that is why you are unable to recognize, but it has, if you notice. So let me dim the light. You are not able to see anything. Sorry guys, no, you are not able to see, but I visibly I am able to see like this, that let me show you with this camera. Low blinking light. But let's forget about the light, because if you don't have a light available on the motherboard, what you will check. So you can see that somebody has already when first time I received this motherboard, it was like that. I have not done anything. Even the guy who has worked on this area, it seems that there was a corrosion and something, and he has scratched it and tried to repair this motherboard. But actually when I saw that there is a PSL logic ought was getting voltage, so that is why I changed this this MOSFET, this P channel MOSFET, and this I thought that it is done, but that was my mistake. And you can see that I have diagnosed this area, that I have just chopped the AC in that PSL in I have cut in order to check, because I was getting voltage on this area. However, the charging IC pin number 5 was not having any voltage, as usually PSL logic requires. But the problem is remain same. Okay, I did not notice. That was my mistake. I just repaired it and I sent it to the customer. Okay, so the light is blinking, and don't worry about the light. How do you diagnose the not triggering case, or sometime trigger and sometime not trigger? So as we have diagnosed, I will not take your too much time, and no, it is turned on. The fan started spinning. The fan started spinning. It is turned on. Why? Because I have touched the PSL area. So what will happen, that you can never leave this PSL logic area, because you will always think that the PSL area is having something problem, and that is why whenever you are just putting solder on this area, or you are just heating up this area, and your motherboard is turning on, so this may mislead you. Okay, now again it is turned on. You can see. Let's wait for the problem. Again it is turned on. This is the problem. That is why I made mistake. I checked, usually I check 2 and 3 times, but simultaneously without taking time. Okay, so now it is continuous. Yes, it started. Problem started. Okay, the light started blinking, on off, but you are unable to see. So in this case there is no variation, no fluctuation. So let's begin from the beginning. How do we diagnose these types of problem? However, I am again telling you, the best opportunity is still going on, and you can take advantage of this. And so as again and again I'm telling, very less time is left, and this is the Independence Day offer, and offer is available for Hindi and as well as English, and there is a total 300 videos of 300 hours that will really boost up your knowledge, and you will feel a different confidence, because everything is there till the generation, whatever is going on, BIOS editing, everything, almost everything is completed in this course. And apart from that, these types, this is the very normal case study, but a very interesting case study we every month include in the paid case study, which will be included in your account. Okay, so if you are interested, you can call on the given number. So 25% is flat rate. Let me remind you that after 15 September the price will be hike, so that is why you can grab this opportunity before 15 September. Okay, so now let's come to the point. We will start from the 19 volt area. Okay, so the biasing I have to check only, nothing else. Let's begin. Again and again I'm telling you the same thing. Many people are praying for us that you keep on doing this types of videos. I'm really very much thankful to all of you, those who is appreciating our effort, and they try to encourage us to make this types of video. And this is very big achievement for us, as we see the comment, your comment, really very positive comment, and I'm again very much thankful, and whole Laptex team is very much thankful to all of you from the bottom of our heart. Now let's begin with the gate biasing. So P channel 1.8 volt, absolutely all right. That was the last one. The first one we have to confirm, and 4 volt around we are getting, so we will think that it is good. So our biasing is okay, and the common point sensing register 19 volt is absolutely all right. Now we will check the 3.3 and 5 volt area, and first of all we will confirm that what is the condition of our LDO. So here is the 3.3 and 5 volt regulator. 3 number pin is 3 volt LDO, so let's confirm it here. Good. And 5 volt, beware, this is the 19 volt and this is the 5 volt LDO. If you touch it together, laptop will blast or motherboard will blast. Why? Because nothing will left. IO may short, CPU may short, everything. So that is why, if you are just getting it confirmed, check it here. Okay, check it here. 5 volt is required here. So around 4.8 and something, but it is fluctuating. There is something problem, or might be problem. And 19 volt, it is constant, it is good. And what about the 3.3? as we have already checked it, but this is the way you should check most of the time. And since there is a PSL logic, we have left one important point, that was ACOK. Okay, so 3.3 volt and this is the 5 volt. Okay, both are okay. Now verify the 5 number pin of the charging IC. So 1 2 3 4 5, here is the 5 number. It should be low active enable, so it is hash, and hash must be low on the ACOK. So everything is all right, but this is the level 1 repairing. Okay, as we have diagnosed and we made mistake, not all the time, but sometime in the hasty, when we have lots of motherboard to do, so this types of mistake can take place. Again, I received the board written that repeat the same problem. It really not make me feel good, but the repeat case is really a wreck of brain. It really, nobody love to do the repeat case. So in first attempt, if you want to do, that is why I'm telling you, just keep the board after repairing at least 10 to 15 minutes and check it again, and then estimate to your customer. So in this way, what does happen, you heat up and some component is open and it start working as you heat up the motherboard. So this process, whatever I have checked now, this is called the level 1. Why? Because we are checking all these things with the multimeter. Now the level 2, how do we confirm the things? With the DSO. Now I have set my DSO and I will check it. First of all, 19 volt I am checking, so I will do nothing. I will just, so let me set my DSO on X10 and let's check the 20 volt. So here is the voltage I'm checking, not on the sensing register. I'm checking the high drive of any MOSFET. So here is the 2 volt and x10 into 2, 10 into 2 is equal to 20 volt. We are getting without any fluctuation and without any problem. So this is the right way to check, because the glitch you cannot verify with the multimeter. Okay, now LDO we have to confirm. So where is our LDO? This is our LDO point, and 3 number pin. First of all we have to verify it. So I have kept it again on X1, and it is giving us a good value without any problem. 5 volt. As again and again I told you one thing, that 5 volt LDO on this type of 3.3 and 5 volt architecture, 5 volt is generated when your S5 enable comes from the IO. Okay, or always on comes from the IO. TPS 51225 or X5 and this types of IC, these architecture always get voltage. 5 volt LDO you will get voltage when 6 number pin and 20 number pin will get enable signal from SIO. And there is the one most important point is tied together, that is your thermal area, and thermal area must be okay. So you must confirm your enable, whether your enable has glitch or not. In fact everything is happening because of our enable. Enable is not stable. Now again we need to reach to the 3.3 and 5 volt area, but something is happening when we are trying to heat up the area. It got okay every time when we are heating up. Now again let me confirm the 3.3 and 5 volt area. Here PWM area good, PWM area good. Outside, so let me check it on the instead of this one, because there are some polish and there is some very trouble to check the output coil. Now that is why you should check here. Why our light is blinking on and off, because our voltage is not stable. 3 volt coming, going, coming like that. And this voltage 5 volt still the same. So all the things is getting impact which is associated with your enable, and enable is your 6 number pin and your 20 number pin. Okay, so if our enable pin is all right, then everything will be all right. So we have to locate that area. 3 volt problem and 5 volt. Even while I thought that let me share this case study to you, what was in my back of mind, that I thought that the capacitor would be leaky. I was thinking when I decided to let's share this experience to you, I thought that might be capacitor would be leaky and I would share with you. But now when I started diagnosing along with you, I am damn sure that there is no problem with the capacitor. Why? Because your enable has problem. So now we need to find out the solution. 5225, and this was the area we have to reach. This is the thing I wanted to remind you, that 3 volt LDO you will get without any enable. As soon as the wind will enter to the IC, you will start getting 3 volt, okay, but not 5 volt. 5 volt will be generated only when your 20 number and 6 number will get voltage, okay, and both comes together. So copy, paste. Now it is going to be distributed into two part, 5 volt enable and 3 volt. One is going on the 6 number pin and one is going on the 20 number pin, but these all are the same thing. These all are the same thing, okay. So let's copy this one, paste it, and here is the area. And this was the area which I was trying to bring your attention, that pure hardware shutdown. If I ask you that what is the responsible to enable 3.3 and 5 volt regulator, so your answer would be most of the time that SIO. But I could show you that 3.3 and 5 volt regulator is enabled by thermal area. Okay, as we have taught in our classes here, pure hardware shutdown is the responsible to enable 3.3 and 5 volt. So it is written here. Okay, remember these important points so that this will help you to repair any type of problem. Now what I need to check here, that D3602, this area, if this area is getting glitch, as long as it is high, this will be high. As long as it will be low, it will be low, because the diode concept, I think I don't need to say you again and again. If this is grounded, the all voltage will be grounded. Okay, all voltage will be grounded. If that is why pure hardware shutdown must be high every time, then only your S5 enable will be stable, and that is how we will get 3.3 and 5 volt high every time when my pure hardware shutdown will be high. So we have to locate D3602. Okay, this has the board view, but Allegro I need to open. I don't want to open Allegro. What was the number? D 3602 here. 3602. I think somebody has tried to change this also, D3602, but I don't know. What is the scenario? Now let's figure out, and this seems that R 1 kilo ohm. If this is the 1 kilo ohm, that means this the 1 kilo ohm resistor is here. Okay, so S5, here we have to check here, this area, this area, also this area, the three area, major area we have to check. Back side of the resistor, S5 enabling, and also this side we have to check, and this side we have to check. Everything will be confirmed here. Now come to the point. Fluctuating, this is not good. This is fluctuating, this is not fluctuating. So what does it mean? That my thermal area has no problem at all. This is the OT area, and OT area, this is the pure hardware shutdown area. I think so, because outside is the thermal hardware shutdown. This area is not responsible of this problem. What is the responsible? My S5 enable area. Now, so it is very easy to find now. This area is having problem. Okay, and let's do one thing, and let me turn off, and let me remove this resistor so that we will verify the voltage is coming this area. So you can do one thing, that you just remove this particular resistor, you will keep on getting fluctuation on this area. So what is the source of this S5 enable? Let's find out. Now S5 enable, copy, paste. the same PSL logic. Again we reach to the PSL logic, power switch logic. Okay, power switch logic, PSL area. So PSL area requires two things. Let me remind you once again. AC in, or what is named, that is the AC OK, is the low logic. So it must come low, and there is a short pad and it will enter into the SIO. KBC power button is the high logic. Why? Because there is the LDO voltage is pulled up. That is why this is the low and this is the high, and both will enter into the SIO pin. This particular area, these particular area, N1, because on off button become PSL2 and AC in become PSL in 1. So PSL in 1 and PSL in 2 will enter into the SIO, and it will auto low active enable, and it will reach to this PSL auto. Okay, remember this thing, it must be low at any cost. If it is getting high voltage, then your 3.3 and 5 volt regulator start heating up in that scenario. Okay, if again and again you are changing 3.3 and 5 volt regulator, and again you are feeling that it is heating up, so that could be reason of PSL logic failure, because it is leakage sometime. So if you remove it, your heating up problem will be solved. You replace it, again it will start working, so your motherboard will come to the working condition. Now I have changed last time this thing, and I got this motherboard okay, and again I got it repeat. That is really okay, let's forget about it. Now this area is having voltage this time, but this area is having problem, which last time I forget to check, because I thought that the board is okay now, but constantly I kept on checking why he has sent it me, because when I received it, it was turning on, and after few moment, like as it is happening now, sometime it's turning on, sometime light blinking. So when I observe the light is blinking, so I brought it to at my home setup, and I thought that I will discuss along with you. So now what is the scenario here, that the same PSL logic voltage comes and become the 3.3 auxiliary KBC, and KBC voltage is VCC for SIO. Okay, KBC voltage is VCC for SIO. Also it is becoming S5 enable for the 3.3 and 5 volt regulator. So when it is low, why it is fluctuating, sometime on and off and on and off. So again I need to confirm my PSL logic. Okay, because there is nothing else problem, I think so. Otherwise I will remove this Q2403, because it is open drain. You know the logic of open drain. If something is open drain, you just remove it. If it is having any problem, I will remove it for good. So now I will locate Q2403, Q2403. If this is the PSL logic, the first one, if this is the PSL logic, then this must be S5 area, but all are changed. He might have tried. I have only done this one. Okay, and I never observed this types of problem in this particular motherboard. There could be, but I never have experience of this type of problem. So first of all, let's fix it properly. Okay, because I never solder like this way. You can see that after using heat air gun, I usually use the iron like this. No loose connectivity, never. Okay, now so this is the S5 area. So first of all, as I told you, that I need to check the 1 and 2 number pin should have voltage, and the PSL out should not have any voltage. So let's figure out. Let me inject power, turn on. This is good. This is good. This is PSL out. Okay, this is PSL out. LDO is generated on the battery. That is the confirmation. If LDO voltage you have started getting on the battery connector, the PSL logic is working. Now S5. S5 is good here. Where I checked. Now this time. Okay. Now how? Let me turn off. Okay. Let me turn off. Turn on. It is on now. Let me turn off. Turn on. Turn on now. Turn off. Turn on. Turn off. Again turn on. What is happening here? Turned on, off. It seemed that something was loose on that point. Loose connectivity? I don't think so. So I just soldered on that area only, because I never use I never diagnose or never put the IC like that. Just heat up only and you just leave it. Never. Constant. It is constant. So if in future it happens, because my S5 was having any problem, so what I will do here, it will never come, the problem will never come same. It is my guarantee. Okay, you just remove the S5 enable open drain logic. Never let it be closed. Okay. As the scenario you have seen that it was fluctuating sometimes on and off, and because any problem, that is only responsible that your FET is leakage, because there is no problem at any cost. My S5 PSL logic is absolutely fine. When PSL logic is absolutely fine, what could happen here, that when my PSL logic is absolutely right, then the low would be coming here, that means that ground will never let go to the S5 enable. Okay, so it will always get voltage. So I have removed this one. When I have removed this one, whether it is low or high, as my auxiliary KBC is generated, at the very moment my S5 enable will be generated. Okay, so that is why I have removed. If in case the problem comes the same, I don't know, because I have worked on this area, because sometimes it works, it does not work, so I don't want to take any risk. That is why this time it should not come back at any cost. I will check it around 100 times, then I will send it to the customer. Okay, now turn on. Turn on, off. Turn on. Not this way. This time we will turn on with on off switch, because quickly if we remove now, Are we getting voltage on the on off switch this time? Again it is happening. See, wow, it's really very interesting case, boss. Again the light is blinking. Yes, where my DSO? DSO will tell me everything. Scenario, this is S5 enable. See, S5 enable is still getting high, low, high, low, high, low. Now outside, good. Do one thing, remove this resistor. This is the main point. S5 is going to become 3.3 and 5 volt. This is the S5 enable, this is the 3.3 and 5 volt enable area. So just move it from one side. Okay, like this. For a moment it will turn on because I have heat up the board. Yes, it is turned on. Good. I need to wait for a moment. Constant because it is on. On. Turn off. Yes, still it is happening. Now, yes. So, can you tell me that what is the responsible to behave like this? So only PSL logic, I think so. But what will happen to think? Good. Yes, 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 yes. This is what I never wanted. PSL logic. Yes, IO is sending or something it is getting. Low logic is sometime getting high. Sometime it is getting high. I don't know why. Let's confirm the pin number. Okay. Then only we can get it confirmed. It's really very interesting case. I hope that you don't get like this type of problem. 73 PSL1, it must be low and PSL2 must be high. Let's see what is. One is PSL1 must be low on 73 number and 93 number must be high. 73, 93. Let's come and see. So 32, 64, 65, 70, 1, 2, 3. That is why I chop this. Yes, it is turned on. Again. Yes, blinking. It is blinking. Now let me test this area only. As I touch this area, you see it is turned on. Now blinking. Now it is turned on. It's on off switch. It's behaving like on off switch. Let me connect the on off switch from this pin. This is AC in. This is the AC in pin, and it is, see, as I will touch, you will see, notice the ampere. Good. So the problem is now this time I will turn off and I will hold it like this. It's turning on as we are touching it, and it is turning on. Now the same thing with the multimeter. How does it behave? That was the DSO. This time I'm checking it here. .4 volt and 5, sometimes 6 volt we are getting on this point. That is not good. Low logic, we must get low. 1.4 volt around we are getting on this point. Charging IC pin number 5, we have confirmed it. It should be low, and it was low. This time what do we get? Let's confirm. BQ737. Good. Now turn on. No voltage at all on this area. No voltage at all. Then we will be getting voltage from the IO side. That will be happening perhaps. Now IO is maybe responsible for it, but before that there are the few things I need to confirm on this motherboard, and so let me confirm few things on the SIO. So guys, as of now what we have diagnosed, I will not use anything because I will heat up and it will again turn on again. Many things we need to verify now. So let me show you that how many things you have to verify. First of all, if you have any PSL logic, usually you will get this types of IC where 288 and 285 and also 885. This IC is also used PSL logic. Novotone, especially Novotone use PSL logic. There you have to check few things. Here is the V bus and V backup. Two things. It must be constant. One is the IO is confirming RTC area is okay, and also LDO area, V bypass area, VS bus or VR bypass, you can say. This area is good. So 75 number pin we need to verify, and 114 number pin we need to verify. So let's come 100, I think 75 number pin. Good. So let's confirm. So in this case we have to always apply level 2, not level 1. Let's throw your multimeter on the back burner somewhere. Never check it. This types of problem with multimeter. So 75 number. So here is 64, 64, 65, 70, 75. Must be constant. So see DSO. No variation, no glitch. It is steady, very steady. Now 114. So 96, 100, 5, 10, 11, 12, 13, 14. Here this line. Good, no problem at all. One important, most important pin, that is the reset, EC reset, 85. Last hope, 85. Even if there is a reset, okay, there is a few more things which you will come to know in our class when you will join it, because there is a basic knowledge we have given what is the basic requirement of SIO. Also there is the advanced level of SIO communication with the PCH. So it is not possible I can describe each and everything. 20 more than 25 classes of 40 minutes of the PCH and SIO communication. There are the various things in the PCH. Here 85. So here is the 65, 70, 75, 80, 85. This is causing my S5 enable ups and down, and my S5 enable is causing my LDO 5 volt and 3 volt S5 and 5 volt S5 up and down. So now you have got the root cause. This is the root cause of the problem. And as you know, the reset always take pull up voltage. So here is the resistor, I think so, and this must be constant. This is also going ups and down. So let's check what is this and how your reset is taken. Not necessarily that it will take the pull up all the time. Now find out what you have to do. Copy the EC reset. Nowadays like Acer Predator, Acer Helios, these models are using EC reset from the battery in sections. There is also pull up is the RTC VCC. So beware that types of model. Even there is lots of problem in the EC reset area. So EC reset again, power hardware shutdown. But if this was high on that point, it must be high, and if this is high, so this is the PNP, this is the PNP, and PNP will never turn on. When it will never turn on, the voltage comes like this and it will go like this. Okay, that must be here. So if no pull up is there, so this will come here and this will also go here, also this will go here, and this will be off, this will be off, and here we should get the steady voltage Q2404 2404. So let me open its board view so that I can check out where it is. So guys, I have opened its board view, and location was Q2404 Q2404 Q2404. I am unable to find this IC. So this is the area, and blue side is my top side. So I have taught everything, all types of board view, how to run the board view is only on the paid videos. So this side is the top, this is the bottom side. So on the bottom side is called the IO side. IO side, the 1, 2 and 3, this was the PSL logic area, this was the S5 enable MOSFET, and this one is the third number is the BJT. Okay, third number is the BJT. So this BJT is the third number. So here is our location. This one, third one. Okay, this is the BJT, and name, I have to find the name also. EC reset is this side. Let me turn the board on this side. So now this is the exact location, as you can see here. Also this is the location. The first MOSFET, now match it here. Okay, so let me move it where it has gone. This one. Q24, what was that? I forget. 2404. 2404, this one. So the top one is the EC reset, this is the ground, and this is the pure hardware shutdown. Everything is written here. Okay, so top one is the EC reset. My EC reset is having glitch, and that glitch is causing S5 on glitch, and that S5 on glitch is causing your 3.3 and 5 volt glitch. Pure hardware shutdown. First of all, we have to check the lower pin. Okay, the lower bottom pin we have to check, and the lower pin, this is the lower pin we are going to check. So I can show you like this way so that you will understand each and everything. Now you will notice it is steady, constant, no problem at all. This side, this is what EC reset is having problem. Power hardware shutdown is not having any problem. So just remove this. So I will not heat up, I will just remove it like this way, so that, come on, okay, it is good, it is on the air. Now I will check the EC reset. Still it is having problem. It's really very much trouble. EC reset is having problem. I really don't know what to do now. Now figure out what is causing this cap at the rate R2424. Let me find out. R2424, R2424. This is the R2424. This is pure hardware shutdown, and this is the EC reset. Pure hardware shutdown, EC reset, which is causing, you will get to know. This is the location. Now let me show you. This is the location we are talking about, pure hardware shutdown. And what is that? The top one. And let me check. There is nothing. There is nothing. This is the point we are talking about. So let's remove this also. I will not use. Okay, I have disconnected it from one side. Now EC reset. I think I will not get voltage on the EC reset. It is getting voltage from perhaps from power hardware shutdown. Now let's find out. EC reset. Now it is good. No, it is not good. It's not good. Still on, off, on, off. Pure hardware shutdown has no problem, absolutely. So this thing happens. I have removed this register perhaps, but R2424 is what? R2424. This is the R2424. Something is wrong. EC reset. This one 0 ohm. I think this must be 0 ohm. So let me set my multimeter to the ohm, and let's find out what is this. Open. This is the 0 ohm track. Okay, from here to here it is track. It is saying at the rate R2424. Once again let me confirm, R2424, R2424. It is saying no, it is not available. It is not available. See, nearby pin it is here, and you will see one, this was second and third. This is not available here. This is not available here. Okay, so it is not connected. Then how it is getting voltage? How it is getting voltage we need to find out. EC reset, how still we are getting EC reset is having problems, so we need to find more. Auxiliary KBC, no more area. EC reset on SIO, EC reset is on capacitor is at the rate. I have removed this. This is not available. Then why EC reset is having glitch? So this time we will remove SIO pin. SIO 85 number pin we are going to remove. Okay, or you just cut it. If it is available, just cut it. First of all, let me verify one thing, that it still has glitch. Okay, it's not very easy case. 85, this is the 85 number. Okay, and let me inject power. Yes, there is no power on. 85 number, turn on. Getting no voltage. What happened? What happened? Once again. Oh, DC jack is auto. Now let me confirm. So chop off the reset area, or you just remove this pin. Okay, so I am going to cut it. I have just removed it in order to verify this voltage. Now both sides we have to check. Still we are getting glitch, and there is no pull up. There is no pull up at all. This time we will remove the pin. Okay, I have just removed this pin. Let it be on the air Now I will check on the air because I want to confirm that there is no really, I have never seen that the board apart from this type of architecture, that EC reset requires LDO pull up voltage. So here the new thing I am experiencing on the pin I am checking. Still glitch. Glitch is inside from SIO. So two more thing we need to check here. Two more thing we need to. Thermal area. Where is the thermal? Thermal area. Let me verify. Let me search it. So I really stuck up, but I believe that I can find out the problem. One thing I noticed that whenever I am touching my on off switch, that is the AC, okay, that will I think save me. See, as soon as I touch here, there must be some problem. As I touch, board turns on. Follow the track. That is why I took some pause. This is the root cause of the problem. It really took too much time. 2 hours it took to reach the problem. However, I was not thinking that this could be the issue, or this could be the problem. Now let me put jumper wire. Also one more suspect, this area. What is this? This is also okay. Let me scratch full. So good thing he has done, he tried to scratch. What was that? This lane, this is also missing. Both are missing, and I don't know which one is the causing this problem, but both we have to make jumper. See, also this area ahead. Good. Keep on scratching. Oh, where this track is going? SM bus. SM bus. Oh, come on. Okay, whatever. This is the SM bus area, I think so. Let's make a jumper wire. Don't care about that. It has taken too much time. Sorry guys, sometimes this happens. I have taken lots of your time. That is why physical is very much important, especially liquid damage case. I was not paying attention, and you have seen the consequence. But one thing, I am very much surprised. The first time I have seen that the EC reset in this architecture only, where 288 is written, and Novatone only. Apart from Novatone, you will always see that this use LDO as a pull up, Now let me zoom it. I cut that track when I was checking it in the office only. I after cutting it, even I was getting some voltage. I was very much surprised that why I am getting voltage when SIO is sending low from the charging IC, but despite I am getting high voltage on the IO side, even if I just remove the track from this area. I must have paid attention on that time. Okay, you have got something new. Now let me turn on. Of course it will turn on now. Now I will check the glitch pin. Yes, this time one thing I have experienced, that this IO 288 has internal pull up. It has internally pull up, no require from outside, only checking the pure hardware shutdown. Okay, so this point should be noted. Now it is high all the time. So I will put back everything, and I think it is done. This time it will not come back. So some mistake gives you point to learn something. I learned something new, and I hope you would have learned something new. You must comment on the comment box what you have learned. No big problem, no small problem. From anywhere you can learn. It's not necessary that a big all the time the big signals, and even the very minor signals could reason. You have seen that SIO sometime coming, it was not coming. Okay, everything is done. Where it has gone, without it it can work, without it it also can work. This is required some of the time. This is the S5 on to 3.3 and 5 volt enable, and without this two FET, this is the open drain logic. This is also checking the thermal hardware requirement, that is the BJT. So I will not use any of these. The only single I have left here, however there was a 3. This was open drain. This is the EC reset logic, checking only with the help of power hardware shutdown. If power hardware shutdown gets low, the MOSFET will the BJT will be activated, and that will low the EC reset. That will cause to stop turning on this motherboard. So that is why I'm not using this one. Also this is the S5, and this is the open drain. So everything is absolutely all right. Now I have to make this reset. Let's check it. Connect it. Should I connect it? It's just checking. Okay, let's connect it. I should not experiment this time. Okay, enough experiment I have done on this. A jumper wire is required. Without jumper wire, This time I hope that it will not come back. Two thing was missing. Really, it was wonderful. He has scratched many things. He has left, even I have left. Now turn on. Alright, every time before sending I will check it, verify it around 20 to 30 times, and I will send it, and rest God knows better what would be happen. So I hope that you have learned something, and these types of case, I was thinking that that would be very much easy, but that is really a raking brain case. So it happens, sometimes you get very easy case, and sometimes the case let you learn something new. So guys, as you have seen that again and again I'm checking it, and absolutely fine, no glitch this time. So finally the glitch point we need to check, verify on this area. However, it is turning on now. This time it is not turned on. So this was the area. Absolutely all right. This is the 3.3 and 5 volt enable. S5 on, I'm checking. Okay, S5 on, I'm checking. It is good. So guys, I hope that you have enjoyed this video, and if you are required our video course, so the very less time is left. You can get opportunity, many case studies, many new things, entire concept from the basic to the advanced, and the BIOS editing, DSO, how you can use the DSO, how can you run all types of board view, Allegro board view, how to run Allegro board view, and how to run Tabo view. Different methods I have described in our course. Here you will get each and everything. So hoping that if you are not feeling confidence in repairing, then you must join this course, and this types of offer will launch in once in a year. So very less time is remaining, so you can contact on the given number for any query. Thank you guys, thank you for watching this video. Must comment whatever your query is, and what how do you feel this case study, and keep on loving us like that. Thank you guys, thank you for watching this video.